Hello, folks. We're just doing a roundtable introing. We'll get to you.
Yeah, wait. From Microsoft, and I just maintain the community and SCD. Yeah. SCD. You see, I'm Sohan. I work at Red Hat. I'm one of the maintenance for that.
That's Peter Hunt, also Red Hat, also Cryo and SigNode stuff.
Great. And can you guys hear us?
We have another person who's
You're pretty quiet.
Pretty quiet. Okay, I'll try to repeat things as best as I can, or we'll figure that out.
Hey,
And-
Brandon. I'm Michael.
Hey, folks. Got myself a mic here.
Hey, folks. Great.
Michael Brown just introduced himself, the other Michael Brown.
Now the other Michael.
Oh, that's right.
Oh,
I know this from before.
Yeah. It's
Right
less,
on cue.
it's less confusing when at least one of you is virtual.
Fair enough.
Okay.
Do you guys want to intro?
Yeah.
Brandon, Mike?
Yeah, Mike Brown, Containerd maintainer. I work on OCI. I'm in the top. Hey,
And Brandon Mitchell, maintainer on my little side projects, Reg Client and Ola Reg, in addition to distribution spec and image spec, and also on the talk.
So, Matt, do you want to kick off?
Sure. So,
Speak really loud.
all right. So, big thing that we on the Podman side would love to get out of this. I have heard that Containerd has done a migration from your original storage backend, like moving to a more modular system. This is something we on the Podman side are deeply interested in. I think you know where we came from. Like, Podman and Containerd had a shared Docker heritage. You're moving away from that. We would like to move away as well. We're at the position where we're starting to be seriously limited by it. At the same time, I'm kind of terrified of this because, by God, changing storage out from under us is the kind of thing that could go very wrong very quickly. So I'd like to ask, like, what have you guys learned from this? Like, what did you think went well? What went poorly? What would you do differently?
And do you think it's keeping up with what's happening out there too?
You want me to answer that?
Yeah, I do.
Well, I mean, the migration, I mean, Containerd hasn't migrated. I mean, we wrote a completely different backend, 9 years ago. So like we were never in like a migration. Docker is in a migration, like in the midst of a migration now, switching from the storage to the Containerd storage. And that is, we'll see, I guess. It's kind of TBD how that's gonna turn out. But for the most part, like, yeah, we've switched the default over now on the Docker side to use the Containerd storage. It's not like the issue isn't like incorrectness. It's more just the stickiness that people have a lot of stuff and they don't want to move.
Yeah, that is my fear. Yeah.
And we've added some like migration scripts, but that's not really ideal. I mean, dealing with like people's pet containers is tricky. People don't want to touch them. But on the pure Containerd side, well, we've never had that problem because we're using the same storage since the beginning. So
Oh, okay.
Would you say you're satisfied though with your like backend at this point? I would say you've got a lot better of a history than we do on this. So, like, are you experiencing problems with Container D? Is there anything that's making you think this is something that I'd like to change? Because, but basically, I'm coming at it from the perspective of I'm about to start writing a spec for what I want, and I'm trying to figure out if there's any advice you'd have for that.
I mean, I think from the Container D side, we when we wrote the new backend, when this was what, 2016 when we started doing that, we had just rewritten the backend that became container storage like a year before that.
Yeah.
And so we knew what the pitfalls were with that approach, because it was like that backend itself was like an evolution of the previous backend that was like the pure graph drivers one, and we added this other layer on top of it. So with Containerd, we took a much different approach to storage. Like snapshotters are its own tightly scoped thing. We have content store, which is its own tightly scoped thing. We have like a garbage collector, which is a completely separate thing. So it's a collection of pieces that work together. And it works together pretty well for us. I mean, I wouldn't say we're dissatisfied with it. I mean,
Okay.
I have a procedural question. Is there like a Slack channel we could use to like maybe share links? And if so, if we have one, I'd love to have a link to like the rationale for this Containerd rewrite. Like, is there a GitHub issue or like anything like that?
From the one that they did in 2016?
Well, I don't know. I mean, is there any document on, I don't know, is there a README in the Containerd repo that like summarizes this or like?
like why we rewrote the
Yeah.
graph drivers.
I think
Yeah.
OpenD has a lot of some of that history and
Yeah, there might be. I mean, we actually had this discussion in
Uh,
2016 with,
Yeah,
with,
maybe it's under, thrust looks under historical, maybe.
yeah, it might be.
Oh, the docs historical.
Yeah, we
yeah.
might have some.
I'll see if there's some, but we don't necessarily have a Slack channel. But if someone, does the CNCF let you just create channels?
I think so.
Yeah, if someone wants to.
We should have a container runtime general channel, huh?
So it's not OCS rec. Can we just use OCS rec? Open
I mean,
container.
I just don't know if everyone's on OCI Slack.
Hmm.
You mean the OCI?
Most of us are. 'Cause,
Oh, okay. I
right,
mean,
we're
if people are.
maintainers, so most of us will have.
That's not the CNCF,
No,
he's talking about the OCI slide.
Oh, the OCI.
Yeah,
sorry,
OCI also has their own Slack.
We're not on that one.
Slack.
Giuseppe might be.
Yeah, that one's.
Yeah, yeah.
So one of the things that's stretching us is, we're based on everything being in tarballs and things are getting humongous, and we want to only, download parts of things, but we need to make sure that the signing is still valid for the entire thing and blah, blah, blah. That's what's really stretching us right now.
Basically, the existing image format. I think that we're starting to run against the limits of what it was originally designed for. And in some cases, push past those limits. We both have our own partial pull mechanisms. I don't think that was ever a goal of the original image spec. And OCI, is it V2 or V3? I never remember. But the next generation of the image spec, from what I see, seems to be stalled. So I start to wonder, are we going to be stuck on tarballs forever, or is this something we should discuss working towards?
Do you guys base it still on tarballs, your rewrite, or you don't care?
We don't care.
That's what I thought,
Yeah.
right?
Yep.
You've abstracted away from that being your responsibility.
And, I mean, the latest thing we've added is AeroFS, which ComposeFS is kind of based on as well. It's very easy to convert the tars directly to AeroFS. So like, even if you're using that snapshot or Containerd now, you can move away from doing tar operations, which is the other thing we don't like doing, is like doing the untar. Ideally, yeah, our goal is to get out of the tar format as quickly as possible. So yeah, I mean, I think we've always supported having a new generation of stuff, but there's always been that like, I was like chicken egg or, but like as runtime, should we do it first? Or, like, are we gonna try to do a design by committee thing where nobody's happy, force that along?
I would say that the signals I'm getting from OCI in some places would be that they would prefer an implementation before they standardize. I'm not speaking about OCI v2 here. Specifically, I've been looking into SHA-512 support, post-quantum cryptography, and the image spec, and that seems to have deadlocked on the opinion that, well, someone should do it first, and then we can standardize whatever that is. I know we have some people on the image committee here who can correct me if I'm wrong, but it just sounds like as runtimes, this is something that we might want to be moving forward on. And then if Containerd and Podman Buildoscopio and Cryo with it were to decide this is a new image spec we would like to implement and were to get some registry support, it seems like we could create a de facto standard and ease the path to a new version of OCI.
So the SHA-512 support was not a problem with image spec. That's already there. It's been there for a while, and I think they're like the Go Digest project already supports that. It's a challenge for distribution spec that we haven't specified how you would push a tagged manifest with a different digest algorithm than the canonical one. That's currently backlogged behind me rewriting the entire conformance suite. And so I am partway through doing that right now and making some pretty good progress. So it is not indefinitely postponed. It's just taking a while to completely rewrite that. The challenge was I didn't want to have to rewrite every one of the tests and double them for every new algorithm we added. And so I wanted to try to make something that was a lot more don't repeat yourself, try syntax.
That is exciting, and I will probably be emailing you about this in the near future.
Is this just if we adopt eStarZD or Sochi as OCI breeder, we can just keep entire compatibility.
Yeah, a lot of those, when you add them as new media types, distribution spec doesn't even care. That gets down into runtime and a little bit of the image spec.
So Brendan, is this issue 548 in the distribution spec, or what's tracking SHA-512 for distribution spec?
Let me pull it up, and if I find it, I'll chime in here. I don't think I've been updating the issue itself. I have been chiming into the weekly meetings, letting people know where I've been at with some of that. Yeah, 548, the refactor of the conformance test is probably a decent place to look at. Or to at least follow, but that one, I haven't said anything over there. I've been saying it in the meetings, and I've got a branch sitting out to my own repo that's tracking the progress on this.
Okay. I've been trying to follow on GitHub and not attending the meetings, which is probably my fault and also why I didn't realize it was ongoing, but thank you for the update.
Yep, happy to chime in. Back to the folks in the room.
So that doesn't really get the like away from tar.
Yes,
of
that's,
getting, I mean, you need,
I think we're talking, SHA-2 512 has deadlines courtesy of NSA.
Yeah,
This
that's what I was
does
wondering
not.
about.
At the same time, though, with AI images appearing, getting bigger and bigger, I think that on the Podman side and the Podman storage side, we're seeing an increasing demand for better solutions. And I suspect you people are seeing the same.
yes. Yeah. We are. I guess like, I know we've talked a little bit about this even on some of the OCI calls around, well, I guess there's two aspects of it. One is like moving away from tar, and the other is like having more like, I guess, support for like a hierarchical hash where you don't have to do I mean, tar is one problem, but I think you quickly find that the problem is that
Yeah.
the sequential hash that you need an entire thing.
At this point, I would say the problem is more the existing spec. And if we were to say that V2 had Merkle tree hashes and a non-tar, what do you call it, compression format, both perfectly acceptable from our perspective.
I'm wondering if from like an OCI perspective distribution, like the tar versus non-tar almost doesn't matter too much from like the registry perspective, but like the hashing does, because if you change the hashing at all, that's a huge change to every registry. And a lot of the solutions, the lazy loading solutions, are like, some of them I'm not a fan of because they basically say, oh, that hash is too much to, like, I can't compute that. So it's like, I'm not even gonna check the hash. You know, I'm gonna, you know, use refers to pull down something else, you know, and skip over the hash, which kind of completely breaks the whole Merkle tree hash in the first place. So like, I'm all for like coming up with a common solution for figuring that part out, kind of even separately from like moving away from tar. Although I think once we do that, then like moving away from tar is much easier.
Yeah, I tend to agree that tar, with all the work ongoing with artifacts, does it really matter from a registry perspective that it's not tar anymore? So the hashing problem is probably the more interesting one. Giuseppe, do you have, I'm speaking for you here, Giuseppe, but I think you're the one who has far more intention on this.
Yeah, well, yeah, the issue is that we have also two kind of checksumming, like the compressed and uncompressed. Like this is also some kind of issue. And so what we did with the standard chunk was, well, I mean, it's based on the same idea of Stargit zip, like you have the DOC, then you have a third digest. But this is not just to the client. Like you still want to validate the entire tarball stream, and so we always end up recreating the tarball, losing the advantages of a partial pool. Yeah. So on the moving away from tarball, like yeah, I see that, well, the advantage of the tarball is that it maps to the, like, to a layer, like in this, the concept of a image layer. Like you can, like, would a Merkle tree kind of image format also change the way images are, like, assembled at runtime? Like, will there still be a mapping to each layer? Like, this is where we had the biggest issues with what we were trying to do, because like Merkle tree a bit conflicts with the idea of layering. Do you want a Merkle tree for each layer, or you want for the entire image? Like, I don't know if it's clear what. Like, because a tarball right now maps to a image layer, like, and that it's more a conceptual thing. Like you have your Docker file and you specify each layer how it will look like. Like, if we will move to a Merkle tree, how that would like be done? Like it's still per layer, or will the Merkle tree be the root of the image?
I mean, it could be both. I mean, if it's a single layer, then there's no, like, it could be a single Merkle tree, or you could have multiple, you could layer them into multiple Merkle trees. I think that's also an area we're not too like opinionated about, because some of that gets into like how image authors might want to build their image and what's more efficient from like sharing layers or like building layers. Because I mean, in the end, we're most likely going to have like an overlay anyways between like the writable portion of a container and the read-only portion. So whether or not there's like one lower layer or like two or more doesn't really make too much of a difference, like at least like from our perspective. But like how each of those layers gets constructed, I mean, we can be flexible about that.
Yeah. My question was more about like now we can look at the like at the layer like the storage unit. You store each layer individually. Like a Merkle tree open up more possibilities because you could then have a file granularity basically. You could point to each file individually. Like on the registry side, how will the files be stored? Like now we use the tarball like the container for the entire layer. Like because when I think of a Merkle tree, I think of like a Git. Like you have each file stored separately, and you can reuse that. Just I don't know with container images how this model will look like. How will behave? Like you will have thousands of small files, and each of them must be stored individually. Like now we are using the tarball. Like you end up storing like 5 or 6 tarballs, and you have your image. Like with a Merkle tree, like how the storage will look like how each where each file will be retrieved, because this is also part of the partial pools story here. Like you want to be able to retrieve each missing file, and now we are pointing inside the tarball. Like we store the offsets and we know where to find that file inside the tarball. Like will the Merkle tree will ultimately find its data?
Can I back up really briefly to like a higher level? I think there's 3 things we talked about so far.
Just a bit louder.
There's 3 things we talked about so far that are kind of competing for change bandwidth. One is the SHA-512 thing, which is like, yeah, it's nice, but like that should be pretty easy for the ecosystem to adapt, right? It's like, well, you update some Go libraries or whatever, and we fix the distribution spec. But to me, the 2 big things that are competing are basically network bandwidth efficiency, like star GZ versus Z standard chunk versus other things. But then, what I want to talk about is compose fast. Like the thing I think we have to deliver is on verifiable on-disk integrity, DM Verity like. That is efficient. Like we just need that, like for so many reasons. And the reason they compete is because there's different types of checksums involved, right? Like that you have to think about how they interact, right? In Compose Fast, everything is based on FS Verity, right? For example, which is not your plain SHA-512 of the whole strike byte stream. It's already a Merkle tree of individual files, right? And then the metadata is itself an FS Verity Merkle tree. And so to me, that's part of the challenge, I feel, is like, I don't know, I've had Z standard chunk versus Compose Fast. It's been in my mind for quite a while. But yeah, I personally think the integrity is actually more important.
Just on one of your points on the change management, capacity, right? Like what of all these things, what can we do? I think one thing we have to be aware of is that we might want to make sure we have to do one of them, right? And we all know that we need to do it. So if we can try to traction on that, because it's an immovable, so it's tough to move that other thing, it's tough to move the OCI period. So that we're going to do something, let's try to move it together at the right time, I think.
Yeah. Well, I guess, are you arguing, or maybe you're thinking about this, should we try and combine proposals? I guess what's not clear to me is how disruptive the SHA-512 thing will. We know some of us need to do that. And if it's going to be hard, would it make sense to roll that in with something like, no, every tar will have a table of contents?
That's what I think. Yeah.
I mean, it's not clear to me, but.
Remains to be seen. We are still Podman land, we're in the POC phase. I'm expecting to have the ability to build and distribute 512 images by end of year, but that isn't really useful because most registries reject them at this point. So ongoing conversations with registries, et cetera, et cetera. I don't know if I have a good answer as to how difficult this is going to be until potentially 3 months from now, when I've talked to a bunch of registries and asked them, what's it going to take?
For the layer blobs, it is a whole lot easier than for the manifest digest.
Yeah, I'm hoping the answer is this is not going to be particularly difficult, and we will cruise on through the layer blob checksums, and it will be a blip on the radar compared to other potential improvements, which would be more interesting, largely because a lot of this should already work. Like, we've got distribution spec work ongoing, but a lot of this feels like it's just registries making some assumptions that would be relatively easy to untangle.
I will put the word of caution out that I don't think SHA-512 has been tested very much anywhere. And so as I've been rewriting conformers, I think the one I ran into just yesterday was the cross-repository blob mount. Everything says it worked fantastic with SHA-512, but then you go to pull the blob you just mounted across and it's not there. And that was in the distribution project, so that's kind of a premier registry example.
Yeah.
Okay, that's good news for me.
Yeah, I mean, I'm not saying it's gonna be easy. I feel like we're orders of magnitude less difficult than a more breaking change
Right.
to the image spec would be.
But maybe we're digressing. I think we just know there's timelines on
Yes.
the delivery of that one, so it makes things move sometimes when you have timelines. So what about Colin's point for you folks? Is this abstracted for you, the difference between like?
I think that, I mean, we like the idea of having the table of contents or some sort of DM Verity like data that could come along, because that's if to do any sort of lazy loading or lazy handling, like you need this data, and ideally this data is part of OCI and definitely part of the image, not something that just gets like bolted on afterwards. And once you have this data, like if you had a DM Verity hash, like that hash should be the hash of the blob you're fetching. Like that should be the content address, or that could be the content address, but that would be like a large change to the registries. Like, okay, this isn't just like SHA-512, but this is like SHA-512 of like a DM Verity, which is like has way more parameters that go into its calculation rather than just like a straight sequential hash. So like I like the idea though of having that information, and I think we could make use of it, but we don't have we haven't had too many experiments with like the not doing block level stuff. Like I'd say most of the stuff we've been playing around with is kind of at the block level, not at like the FS Verity level.
Well, yeah, that's what I wanted to chat about, because yeah, I heard that there was something like going on with the AeroFS snapshotter and DM Verity or something like that, because
Yeah, I just put the PR in the chat. It's only 18 hours.
But the DM Verity is generated on the client side. It's
okay,
it doesn't come down from the registry, so we can't use it for like lazy loading. It's just like, that's just like an integrity check on the local system.
Right.
And I'm not sure that like, because the DM Verity data can be very or like specific to a particular machine. So and it's like very granular, like you don't necessarily want to distribute stuff in like 4K chunks. You probably want something a lot larger. So even if we went block, even if you were distributing stuff with like or like a Merkle tree of like blocks, like you wouldn't necessarily want the blocks to be that granular as you have in like DM Verity.
yeah. Well, so
I haven't dug into this, but this is, yeah, I was really interested in looking at the architecture of this one. In a nutshell, my HackMD, the beauty of Compose.fs is that it's all file system, like, which just meshes much more nicely with containers, which are basically file-based, right? In a nutshell, in the current design proposal for Compose.fs plus OCI, all we need to include in an OCI image to get on disk integrity is basically one additional checksum as a label. That's it. There's no additional like look-aside data that needs to be fetched. We don't need to like, yeah, and it's like the nice thing is abstracted over the backing store, right? And we get in memory like page table sharing of content and on disk. Like if you have a duplicate file in different images, we can dedupe it on disk efficiently as well. So like to me, like I mean, DM-Verity is a proven technology, and I mean it's been around a long time. Compose.fs is much newer, but yeah, has those advantages. That's why I like it a lot. How the details of what goes into that checksum, in a nutshell, the downside is, well, it's actually pretty similar to this DM-Verity AeroFS. It's like, anytime you take a checksum of something, I think as you guys know, you have to like, how exactly did you make that thing becomes a very important thing because you basically become glued to it. And exactly how you translate a tar to an AeroFS, well, if you have a checksum of that you signed, well, has to be 100% reproducible, and you just can't change it ever, right? And Compose.fs kind of has that same problem. We have basically a custom AeroFS writer that is different from makefs.aerofs that kind of frozen for this reason, which is sort of downside, but.
I mean, one of the ways I think we're thinking about it is, at least as a way to get away from kind of tar only, is just to distribute the AeroFS directly so that there's no, I mean, one of the big problems with tar, other than just, it's like, well, there's two problems with it. One is that there's a hash mismatch between the compressed and the uncompressed. So when you have the compressed data, it doesn't represent, like, you can't use that to like tie to what you have on disk. And the second is just all the processing that gets done on tar on the local file system. We'd like to avoid that, and many cases like not do that if we don't have to. So like distributing AeroFS in place of like tar-gz like helps, but that's a huge compatibility thing. Like if we were to just start distributing AeroFS, then nothing would work except for like the latest versions of the runtime that's supported. We thought about distributing both, and that's probably what, no matter what gets done, we'll have to do in this. And like, I guess unless you go like the eStarGZ route, like you're stuck kind of distributing two things, or
yeah, I mentioned this in my markdown. Yeah, so the other thing in the ecosystem I think we need to keep in mind is like the scanners, right? It's not just the runtime and the registry, but like, you know, people want to run scanners, and like that gets into the second problem with shipping AeroFS is, well, okay, the AeroFS kernel module's fuzzed pretty well, but still mounting untrusted file systems is like a whole other level of risk. Now, I know for some of you, for those of you who are following like Linux kernel development, right, like there is like all this stuff about maybe we can move file systems to user space, make Fuse more efficient, et cetera, et cetera. But today, and actually AeroFS has Rust readers and writers, which is good, but still it's totally different parsing an AeroFS versus parsing a tar, in my opinion. And like, yeah, we want to support untrusted images. There's a kind of conflict between these two things, right? Tar is very easy. Well, yeah, it's much easier to deal with from that point of view. To the second point, like the dual representation problem, Giuseppe raised this. It's like, well, so we know it's hard to change format, so we'll ship two. But what we ended up doing for Z standard chunked, and he mentioned this, but I don't know if you all caught it, is that so today, the original Z standard chunked in containers image and containers libs now today, you know, is network efficient, right? You only fetch change blobs like eStarGZ does. But the problem is because you have two representations of the metadata of a container image, you have the table of contents, and then you have the tar headers, like what you see if you just parse the tar and ignore the table of contents. Well, it's possible to craft a container image that if you pull it with Z standard chunk, and I think the same is true with eStarGZ, would appear to be Ubuntu, where if you process the tar, it would be Fedora, or whatever. Like you could hide a binary, right? You know what I mean? You have two representations of the metadata, and that's kind of an ugly problem. And so for that reason, containers libs now resynthesizes the entire tar client side, which like doesn't ruin the point, but it makes it a lot worse. So that's another problem. Every dual representation will have that, right? Of like, well, you have a DM Verity ArrowFS over here and a tar. Well, we definitely need tooling that's going to make sure they're actually in sync, right? I think.
Mhm.
I think that's an issue that's been around. If just with as long as the index has been around, like there's nothing that guarantees that every platform and every version of the image is the same, other than signatures over those images.
Yeah. Well, I think scanners know about that, right? Like scanners today crack open multi-arch images and they can scan each arch image, but yeah, but this would be another thing they'd have to be aware of. Sorry, yeah, just in a summary, my pitch is the nice thing about ComposeFS is the design we have is we just have a new label. There's no shipping ArrowFSs on the wire, none of that. There's no, like, that's it. That's what I like about it.
But it can only be mounted in user space.
No, well, there is a Fuse implementation of ComposeFS, but yeah, I mean, it would be mounted as, it's mounting it as any other overlay plus ArrowFSs. Like there's three ingredients, right? It's just wiring together three existing kernel ingredients, which is FS Verity, overlay FS, and ArrowFS.
So I think I remember seeing that. It's using the overlay metadata in ArrowFS, right, to point to the files.
Yeah, there's a redirect. So we taught overlay FS how to require verifying the FS Verity digest of files. And so, yeah, that exists in the metadata as a redirect. So that's the big change I'd like to land to OCI, but then like, I mean, we've rewritten most of it in Rust now, but I mean, it's not complicated stuff, so we could probably have a Go implementation too.
So what would be next? So we have basically, we need to figure out what is the most important.
I mean, we have two problems. We've established that. Well, we have three problems, but let's set SHA 512 aside for now. I think we're looking at two separate things that we could look at for next generation images. We've got Collins on disk representational integrity, and then we have improving network efficiency in wire format. And these are kind of in opposition. Colin is distinctly on the on disk integrity thing. He has interest in that area. I am getting pressure from people who would really like the wire format and network efficiency stuff. It doesn't sound like we have an easy way forward that satisfies both parties.
We can merge them, it's just really hard.
Yeah,
But
easy way, what I'm saying.
I can barely keep Z-Stern chunked in my head and eStarGZ and stuff. But here's my pushback. My pitch is 90% of people don't know, I feel like, how to build images in a reproducible chunked way. Like there's a really great blog post I found super inspirational from the Nixos folks of like, you know, they have a Docker image builder, the OCI image builder that just, you know, generates reproducible split tarballs, right? It's not hard. It's very difficult to do in a Docker file, really hard, but kind of possible. But people will have custom builders, and once you do that, that and shipping OCI models as uncompressed TARs, which you can do today. Like, my point is, those two things, they're not perfect, but they solve a lot. And then if we made it so that I could ship 500 layers efficiently in an image, which is mostly an implementation detail, like, I mean, this is the thing, right? Like, today, Containerd and Podman both mount an overlay per layer always, right? But you don't need to do it that way. And it's kind of silly, right, from a kernel level to traverse 500 plus mounts instead of, we could easily squash client side, right? And I could have 500 layers. It's like, why can't I have a layer per package in my large image, right? Once you do that, it's not bad, right? That's my take.
I mean, we could. There. I don't fundamentally oppose this, but it does feel like I don't know. It increasingly feels like we're patching holes in a very sinking ship. We can improve the situation, but at the same time, it also feels like the people who are asking us for network efficiency are just going to keep scaling the models at the same time. So
the problem is too, right? Like, okay, so we can do chunking, right, and byte range requests, but then a lot of these things have internal compression, which just
Yes.
ruins chunking, right? So
Mhm.
I have been assured that this is not a problem, and I should still be working on all these lovely things that will make it possible to fetch specific things and do diffed requests. But yes, you're completely correct. I have not received adequate answers as to whether the AI folks are actually going to take full advantage of these, or if we're just going to continue in a way where any change to the model is going to change every single bit,
Well, that's
and
the
what
worst
we
part.
just didn't matter. Which is a fancy way of saying that I would love to see network efficiency changes. This is the kind of thing that would have major impacts even on bootc, the ability to go beyond z-chunked and have even more granular pulls. I mean, if we've got to say a 3 gig binary blob and you change 1 byte, it would be lovely to pull that 1 byte. I think there's a lot that we could be doing there.
But I think the issue you're talking about where they can change everything, right?
Yeah.
If there was a huge payoff for not doing that, people aren't going to do it. Do you know what I mean? Whereas right now, there is no
Fair,
payoff to
fair.
be good about that. So who cares, right? Like, if you have your underlying operating system, you screw it up because you switch everything around, then you'll stop doing that. Whereas right
Fair.
now, no one cares.
So lazy loading might still work for AI in the case of RAG. So ML still can't be lazy loaded because every single bit is needed. But for RAG, you can just mount directly with a bunch of information source to be queried by LLM. So you can just use lazy loading or a directory for RAG.
Okay.
I mean, yes, that is. It's certainly an option.
Mm.
I have an instinctual dislike of it, but I can't think of any logical reason why it doesn't work. I'll put it that way. I mean, this could just be me thinking that we need a more fundamental solution, but if it works, it works.
Oh.
So, are you guys pushing anywhere on this right now, or do you want us to we can create some sort of channel where we keep up to date on
We can, I mean,
what we're thinking about next? Because it would be obviously, if we're trying to make stuff happen in the standards, right, then we should act the more people that get on the same train and
Yeah.
better chance of something happening. And I'm sure underlying wise, we don't care we just want to be able to do this, right? So that we can handle bigger images and not have to copy all these things all over the place over and over. And, our Z's, like I think he was talking about our Z standard chunk, because of it opening up certain opportunities, we lost some of the speed advantages because we have to reevaluate stuff. Because there's the space advantages, but
I
we
mean,
lost-
it's security more than space advantages.
no, but the security costs made us stop getting a benefit.
Yes.
Right? So because of, rebuilding, as far as I understand.
Yes, it was a security matter, right?
Yep. Well, Giuseppe knows. So, say that again, Giuseppe?
Yeah, I mean, yeah, we lost on the speed because of the security concern, but we
Sure.
still have some other benefits are left.
Yep.
Yeah, storage, network, and also memory because yeah, because in a ComposeFS setup we are able to share memory even across different layers. If the same file is present in different layers, we store it just once in memory. Which is not possible with a default overlay configuration, where each layer is a different directory. So, yeah, and the part that Colin was talking before, like we really don't know to solve the integrity part, like because ComposeFS is, well, it's built on top of on one side that runtime on the kernel features, and in the OCI world, like reusing tarballs and putting metadata on top of that, like yeah.
No, I mean, I think the proposal we have in the ComposeFS repo does solve integrity. I mean, it implicitly, the checksum is over the flattened file system tree. I mean, I think the interesting debate, right, is like, yeah, ComposeFS versus this container DPR. Wow, 12,502. That's a good number. Yeah, but honestly, we could probably have a side meeting about that. I'd like to, yeah.
Was it the DM Verity PR?
Yeah, I think it imports a new Go library, so it's probably pretty solid. But I feel like, I mean, there's a bunch, we're kind of talking on multiple levels, which is obviously there's a lot of interesting things to discuss, but these are all separate concerns. Like Container D is really not doing any OCI. I'll look around and make sure I'm not, no one else has a different opinion, but like we're not, all the innovations that are happening are like everyone else working within the confines of the existing specs. Like,
Mhm.
and there was a big OCI v2, which was never a real thing. That it was a moniker given to a set of discussions around like what's next in like 2020, when everyone had nothing to do and we could be on Zoom all day. And so you can go find all those HackMDs, but there was no one like with a clear path forward. So it was just a lot of interesting discussions. And I think it would take, I mean, first of all, as we found with like, was it artifacts or the, one of these long discussions in the OCI is like, and Brandon is probably better to speak to this than me, but like, the further you get down that path, it's like, do you realize all the people that expect things as they are? Like, how are you going to move an entire ecosystem to something new? And so every time we've gotten close to that, everyone's kind of like, wait a second, forget it. Well, and I don't mean to be defeatist about that we can do something new. I just mean that's a valid concern here, and that's led to a lot of people just kind of working around, what we have.
Mhm.
And I
I've been silently screaming at all the comments saying to transition away from tar, just thinking of how much code out there is hard code to assume everything is a tar layer, from vulnerability scanners to who knows what out there.
Sure.
Well, and I'll say like, as with Container D, we consider like as a runtime, if there's a format that people want to run and is out there and it exists, like we'll update Container D to run it. But as a runtime, it's hard for us to define a new format for what runs and then go tell everybody who builds it, say, hey, build something like this so that you can run it on Container D. So
Mhm.
it's almost like, sure, we can support ComposeFS, we can support, we do actually support ArrowFS. You could use ArrowFS instead of tar and Container D and it'd work, but nobody's building those images. So like, does it matter that it works? Like the images don't exist. So like we can certainly in Container D add support for all of these things. But the folks to get on board with that are the people who are building the scanners and the registry.
Yeah.
I almost feel like the runtime is like the easiest one, because like sure, if you can come up with whatever format you can come up with to represent a file system, we could reproduce that file system and give it to a container. Like that's not too hard. Like it's just like network protocol and whatever way to set it up. But
There, yeah.
Well, I think something that could help, I mean, within a single domain, right? Like, so I know some group was working this, like the Dragonfly OSS spoke to something. It's like, yeah, you can't change necessarily that container you're pulling from Docker Hub or whatever, but like within a cluster, you can ingest that, transform it into whatever format you want, push it to some look-aside, maybe your registry, maybe you decide you want to use ArrowFast and sign it and like do whatever you want inside your closed loop, right? I know some people were doing things like that. So to me, like that's a good way to like prove out code, right? Within a single kube cluster, it's like, yeah, you turn on the flag and we do that to your images, right?
yeah, GKE has that with the GKE streaming. NVIDIA had a talk on that yesterday that they're doing that. So like, but that's all done as just like, from a community perspective, it's just like a plugin. It's just like, yeah, tar stream goes in and a file system comes out. Like it doesn't really matter to us. Like if that's like a virtual, like if that's like a virtual block, whatever they're doing, like it doesn't really matter from like the container runtime perspective. I mean, if it's like tar coming in or ComposeFS coming in or ArrowFS coming in, it doesn't really matter. It's just like what comes out is going to be a set of instructions for mounting it in the runtime. Like,
Wait, is container D already pluggable in that sense? Like there's.
Yeah, that's this. I dropped the snapshot doc.
So something we threw in the spec a while back, thinking along these problems, was that when you have a multi-platform index, you can put the same platform in there multiple times. And the thought process behind that was tools that follow the spec are supposed to pick the first entry that matches what they're looking for. So if they're looking for Linux AMD 64, they find an entry that says that platform, they pick it. But if you have a second entry in there, that could be for a different layer compression format or, a non-tar format. That would give you a way to package and ship those in a way that wouldn't break existing clients. They could still fall back to the original tar, but new clients could see, hey, the new format's there. Let me move forward to that. I don't think that's something anybody has really taken use of yet, but I just want to point out that does exist as like a forward option.
yeah, we have a proposal for that in Container D using the OS features, but where you could basically, but that goes back to the same problem.
The representation problem.
Yeah, you have two different versions, and if the scanners are only looking at one and the other one is just completely separate, and that's why I said it's at that point it's more about getting the registries well, the registries probably don't care, but getting the scanners and the builders on board, because the builders are gonna be like, oh, now I have to build twice. Like my image is gonna be potentially twice as big or whatever percent larger, you know, the pushes are gonna be twice as long, and then, the scanner's gotta scan twice as much and whatever in that case.
I mean, from my perspective, I would be fine with baby steps. I would be fine with, we supported,
Well,
Container D
should be
supports
baby
it.
steps.
It has to be, but I would be fine with the runtime supported, and maybe we have one or two, we've got the reference registry that supports it. Maybe we have two registries other than that supports it. Maybe 5 security scanners know it exists and know enough to tell you that there may be a problem with your image because there's another representation we aren't scanning. I don't know. Any progress in this direction would be a feature in my eyes.
Well, and then you see which one takes off too, right?
I to a degree, but anyways,
No.
I
I don't mind a bake off of like, try different things and see
That's
what
right.
works.
yeah. To me, it's just the problems seem insurmountable, but if we keep letting them be insurmountable, we're going to be stuck on tar in 10 years and 20 years. And I think we've already pushed tar to the feasible limits of what it can do in many senses.
Well, maybe that's what we think about is how we can do some baby steps with collaborators.
Well, I think our standpoint has been a little bit that Aerofest could be it's a small step to move, but has potential large, like there might be some disagreements between like, oh, should I mount this like block device versus like in kernel space, or should I mount it in user space? You know, and I think some of that gets down to like how do you trust an image and getting into image verification and like everything around that scheme. I mean, theoretically, if you have all this stuff, like, do I trust this image? If I trust this image, I should feel fine mounting a block device in kernel space. Like that shouldn't be an issue. If I don't trust this image, maybe I don't want to mount it in kernel space because like I haven't massaged it. But at the same time, it's like, well, if you don't have a block device and you have a tar, well, now you're massaging the data and a bunch of things. And maybe some people think, you know, changing the file system to be localized is good. Maybe others think, hey, I don't touch the file system at all. Like that's bad. So it's like there's a difference of opinions, and that's kind of why I said like, well, maybe we just don't care too much on the runtime side. Like I'd rather support two things or two opinions and not have to like, I don't want to make that opinion and say like mounting block devices, mounting an untrusted block device in kernel space is good or bad. Like both are valid opinions.
Yeah,
but
I get
like,
it.
I think from the community perspective, like, yes, we're moving in the Aerofest direction. And I think ComposeOS is also moving in the Aerofest
Yeah,
direction.
it's very different. So 2 points to what you said. First of all, in as of Linux 6 something, maybe someone else will know, Aerofest has file back mounts, which was really nice because then you don't need to have a block device to mount the Aerofest, right? So that's just cool. You can just, you don't need a loop, right? You can just mount it. That's nice. Because loopback is not namespaced, right? So if you get into like nested containers, it gets super messy, all that stuff. So yeah, file back mount's cool. But ComposeOS's use of Aerofest is only for the metadata. And that makes it fundamentally different from what this Aerofest snapshotter is. It's like our relationship, the ComposeOS relationship to Aerofest is more like, ComposeOS is more like a table of contents that you could mount, I guess is the way to think about it.
Yeah, I mean, I get that. But the whole point is, I said we're moving in Aerofest direction. Aerofest is flexible enough to do that.
Yeah.
That you could have file back mounts. You could have one massive Aerofest file. You can just have an arrow, or you can have a metadata only. Like there's probably like 5 different ways you can compose like that. You can take a tar and compose into Aerofest and be fine. Like we have, I don't think we merged into 2.2, but we have like tar backed Aerofest support as well, which is just like, it just takes the tar, it decompresses it, and it just adds the adds the Aerofest metadata on top of it. Like you can do layering or non-layering. Like there's a lot of stuff we could do. So like we're kind of exploring in that area, and like the Aerofest snapshotter is probably going to have more features. Like I mentioned that earlier, it's like overlay is what it is. Like we're probably not going to really touch that, but Aerofest has a lot of possibilities that we could do with it. So
So JC previously was possible with Aerofest. Basically, is also possible with LFS.
Is what possible?
Reproducible?
Basically,
Oh, lazy.
Oh,
I mean, it depends. I mean, you could. I mean, I think that's where it gets into like if it's a block, like if you're just mounting a straight block device, you could. I mean, in theory, I mean, like if you were using maybe. And they're pretty flexible, I feel like, in trying to support some of those things with AeroFest. Like if they, for example, if they wanted to just support like the start easy format or something, they might do that, which would be interesting. But the limitation right now is the fact that like the tars are compressed, and you could generate the AeroFS metadata on the uncompressed tar, but then you're not going to be able to use that for label, which is kind of unfortunate. So. In theory, if you switch to uncompressed tars in the registry, you could lazy pull pretty easily using AeroFS over the other approaches.
Like I think to me, what I want, so the nice thing about Postgres is splitting up metadata from data. So, and the number one problem with OCI and tar is timestamps. Because again, you can generate nicely split up reproducible containers that optimize both pushes and pulls if you're very careful about how you make the tar, that you don't just let the timestamps drift, right? But if you split off the metadata as the table of contents is doing, and you only identify files by a content digest, then it seems like a straightforward extension of the registry to just have the registry be able to store like a kind of free floating large file, whether that's an AI model inside a layer or like a large Go or Rust binary or whatever. Like that extension path seems clear to me. We split that up, right? But like the RFS snapshotter is still combining the data stream and the metadata stream in one big blob. And the AeroFS format doesn't have the digests of each file inside it, right? I don't know. So yeah, I think it's useful to split those up.
I was coming in, it looked like Brandon was smirking at it. I can't tell.
I was grinning when we were talking about changing timestamps on layers, just because I know how many people have worked on that same challenge. I know Akihiro has done a lot of work over there. BuildKit, his work over in BuildKit, I've done in Reg Client. But there's also a bunch of other builders out there that just pick a certain timestamp for when they build it. Put that in the layers.
Yeah, so timestamp can be just modified in the build exporter by specifying source date epoch and write timestamp option to change the timestamp. So this will be the bigger problem is that how to pin a cache of apt-get and apt-get. So in the case of Debian, we have a snapshot.debian.org and snapshot.ubuntu.com, but those snapshot servers are quite slow and almost useless. So the problem is how to retain the cache of packages and how to manage the signature of the cache.
So I have a really strong opinion on this, and I may do it for RHEL actually, which is so Amazon Linux, by default, they do this cool thing where they bind their packages to the version of the AMI. So if you boot in Amazon Linux to AMI and you DNF install something, you will always get the exact same thing. And I think that's the way everyone building an OCI container image, base image, should do the same thing. And further, the obvious thing to do is, it doesn't make sense to have a totally different storage backend for all your packages. Like in Fedora, we do this wild thing where we host our containers on Quay, but if you DNF install something, it goes to like this mirror network of like some university over here contributing. It makes no sense, right? Store the packages as OCI artifacts in the same place. You store the containers, and then you just have a compatibility metadata server that serves you that content. And then the two should just be lifecycle bound. Yeah, I really want to push for this because like every day my CI flakes because of one of the other two. Doesn't make sense to have two.
Okay. Well, good hour and something discussion. So what maybe we talk a bit about like some perspective, like some things we think we could start stepping out into and get feedback on whether that's the right direction.
I guess does any of this solve the AI like massive file problem
Well,
that's like,
I
I feel like
mean,
you started with that and we talked about a bunch of stuff, but like does Compose FS really solve that? I don't think they're
no,
really
no,
solving
not
that either.
really.
I mean, other than not copying from like a giant tar thing into like something, and it's just like,
the Giuseppe, for handling the super large file move around problem and changing, right? Like in a super hard, huge file changing, but you really only care about this much that changed, right? Problem in AI. Any comments?
Well, partially, well, we slightly improve that because if the same file ends up in two layers, with the standard chunk, we reuse the local copy. But I don't think this is the like final solution to this issue.
I mean, there's discussion about chunking single files into multiple layers, so you can grab just the layers that changed in theory. But now we're talking, I mean, Colin has already mentioned collapsing multiple layers into a single overlay. Now we're doing it by obligation because we have a single file that's multiple layers, God help you. I don't like this because now it feels like storing file diffs instead of whole files is probably going to make registries' lives a lot harder. I have no data to back this up, but it feels like we're probably going to be reducing sharing as opposed to increasing it, at least initially.
How much is
Oh.
that really a registry problem versus more like a runtime problem of how to apply the file diffs? Because I feel like for a
Well,
registry, if it shows up as a blob, we're not going to care. It's just another blob to us.
That's fair. I mean, the
Yeah.
diffs problem is also interesting. I feel like it's tractable. There are enough existing solutions to binary diff that I feel like this is a tractable problem as long as you choose one. It's just that they all have their own disadvantages, and I haven't done enough of a survey to say which one is the best.
So, yeah, we didn't talk about pre-computed deltas at all, because that is the big third thing, right? Like, but the Flatpak folks did create an OCI delta spec that basically, I think they did it right. And I think it would make sense to float, but yeah, I mean, there's three levels to this, right? There's like, it's another JSON thing, sure, right? There's uses OCI refers to find the additional pre-computed delta, great, that's pretty obvious. But yeah, the point that you made is right now, the Flatpak OCI delta spec basically just says use BSDiff over the entire tar stream, which is pretty suboptimal because BSDiff is very CPU intensive, especially on the server to build it, but also somewhat on the client. And this is where, again, like you really want to split up your layers and not BSDiff a single giant gigabyte layer, because you will be paying for it in CPU time. And yeah, there's a whole bunch of other choices as far as like binary delta formats, right? Like Google just created a new one that's even more optimized for executables. It's like the successor to Courgette. I think it's called Zucchini or something like that. And so, yeah, those things are their own wild world. Yeah, if no one's ever read it, the BSDiff C code is the most inscrutable C code I ever read. Yeah, far from the standard.
I'll also just say that it feels like if we do this, we're going to be blowing build caching out of the water. I mean, we've turned from layers being a caching solution to, oh God, now I'm going to binary diff a massive file and recompute all the layers. And God help me, I don't know. I don't know until I'm done whether any of these are actually cache hits because I have to diff the file in order to figure out which layers changed.
So back to your question a little bit, what I'm maybe naively thinking, is that part of this problem is we need to move forward, but keep people running, right? And so we have many problems we're dealing with and, we need to solve this AI problem, but there's, it's not just one. So we need to solve, how do we move forward to allow different things to happen, everything else works the same, and explore different ways of how do we do that, right? And then we could be saying, you have an AI use case, you got these huge images, you're gonna check these dashes, you're not gonna be using the normal tarball build thing, right? And you just, if you click the wrong things, it won't work. You know what I mean? And then we get a registry to play with us and somebody else to play with us and see how we can make that in, slow growth, baby step stuff happen. And do we need to change any OCI stuff to make that work? I don't know, like maybe, but that's the answer we sort of have to get to, and then we can make it so that it supports, if you have these options, it supports compose FS all you want, or this option is for lazy loading or whatever, or it's a combination. I don't know. But we don't know how to, right now we're stuck in that, I think, place where we can't destroy the old stuff, right? We have to figure out how do we incrementally make it not matter. Like, I mean, at some point in time, people will be like, who uses that anymore, right?
I mean,
But it's not like that now.
that is the core problem. I don't know how much further we can go while maintaining compatibility, so.
But I'm talking about, you don't maintain compatibility, you have.
But if we're breaking, then
Compatibility with what though? Cause
Yeah.
like, there's certain things like, I think to me, registry compatibility is probably the
yeah,
hardest.
that's
one.
mostly my,
So I usually, the first solutions I would even think about like playing around with would have registry compatibility, and then probably like, how do I build this, so that I can actually run it?
Yeah.
Because no matter, like, I've had a lot of ideas for things. I'm like, that seems like a cool thing to support on the runtime, but I don't even want to go about building it. Like, that's kind of
Yeah.
an ugly thing, but like, yeah, the compatibility on the builder side second, but like, I don't know, maybe because I work on the runtime, so that's where I feel like I have the most control and can like actually see the changes happening. Like, it doesn't seem that hard to me to support some of this ideas on the runtime side.
for me, a lot of these are prerequisited on our storage rewrite, but we're already doing that, so I don't. Once storage is rewritten, I can be in a much better place to start moving forward incrementally. And honestly, as we do the rewrite, we can start enabling these things. So I don't view that as a serious problem. C storage.
Oh, okay.
But what do you call it? I do have people who work on builder reporting to me, so I can, if I say that we want to do a new image format, they will glare at me, but they will probably do it. So I feel like building isn't as big of a barrier for me. The interesting thing is if we do anything that requires registry changes or would otherwise, how to put this, registry changes are my big thing. And then anything that depends on us that will be broken. Security scanners, you mentioned, other things of that nature. Yeah, I have concerns about that. Which we're going to break them. I don't see a way around it. I mean, the other reason I'm probably more blasé about these breaks is that I'm already living in a world where the government is telling me they need SHA-512. I guarantee you that's going to break security scanners already. I'm living in a world where everyone is already broken and they don't know it yet. So I'm wondering how much I can sneak in at the same time, if that makes sense.
You have big problems on the build side, you just asked Tom. Thomas to build.
He's very no comment.
Is SHA-512 on the container D roadmap at all, or?
I don't even know if it's supported or don't support it, but I don't see why we wouldn't support it.
Yeah.
Whatever's in Go Digest.
Yeah.
Yeah,
I-
right.
So
I
then it's
don't
going
think we've ever
through,
tested it. It might just
Yeah.
work.
Yeah,
well,
it's something that
will work
it's something that
eventually.
just works for most blob operations and tools today.
I mean, yeah, the thing we don't like about SHA-512 is just if you are doing multi-hashing, trying to store both hashes, like maybe the registry should do that, but on the containerd side, like, yeah, we don't have anything like that.
I mean, we have thought about multi-hashing. I'm at the point where I've thought enough about it to think that it's probably not worth the effort.
And it's not necessarily good because we always compare a hash that we compute against something. So unless we're storing, or unless you're like saying, here, I want this thing, these are both hashes.
Yes.
It's like there's no way to say this SHA-512 is always this SHA-256.
I mean, the alternative is that we use, I believe it was already mentioned, the support for manifest to have multiple versions of the image exactly identical except. So we have the SHA-512 in the manifest and the SHA-256 in the manifest. At which point you get into the representation issue again, where you've got multiple copies of the image. Is my scanner going to get the right one, et cetera, et cetera. But it still seems to me that that's a better solution than trying to do multiple hashes inside the same manifest, even if I'm not the one doing it, the registry is.
Wait, sorry, does multiple hashes mean like, so OCI layers can have annotations? Would that mean keeping SHA-256 by default, but having an annotation with SHA-512? That's what you mean?
Yeah, it would provide a degree of backwards compatibility. It
Yeah.
would. It's very attractive on initial glance because, in theory, it acts just like a 256 image until you get into the details, and everyone else just looks at this annotation and says, "Oh, cool," and discards it because it doesn't matter. Once you start getting into the details, like oh god, the refers problem. Like, what do we do if we get a SHA-256 request for this SHA-512 image? It has both. Is that okay?
So the way my interpretation of the refers is, and
Yeah,
spent too much time looking into that code. I have treated it as whatever digest you put in the subject, that's it, and that's the only thing you're going to get back. So if the subject field contains the 512, then you've got to query refers for the 512 to get that subject.
I think that's what makes it so much less attractive. Once the registry becomes involved, all of a sudden your beautiful dual hash image isn't acting the way you would expect.
Yeah.
All of a sudden you've got so many little holes that are gonna cause problems.
I have not treated it as dual hash. I've always treated it as a single hash. The challenge we've got right now in distribution spec is that there is no way to push a tagged image with a client suggested hash algorithm. The client doesn't have any control over what hash algorithm the registry picks for a manifest if you push that manifest by tag today.
Yeah. No. And that's a spec change, right?
That is a spec change. We're proposing it. That's also part of the stuff that the conformance test is kind of backlogged behind or holding up.
This is only tangential, but kind of relevant, like in composite fast, because it's asked by severity, the kernel offers SHA-512 and 256 as choices, and like you got to pick one. That's why I wanted to avoid doing both. I just decided for Bootsy's use case, we'll always use SHA-512 for the FS Verity stuff. Just data point.
I mean, the fun bit is that NSA reserves the right to say 512 is insufficient to the task at any point after 2030. So whatever we do has to be truly crypto agility, or whatever the term they love to use is. We have to future-proof this for whatever comes next.
Yeah. Well, we have minutes recorded, but yeah, I think let me think about like a strategy there. I think we just have to have some sort of agreed upon a like, almost like a spiky thing to see about what,
Yeah.
where can we start stretching a little? And,
Can you tell us more about the storage rewrite that you're doing? I think we kind of started there and then.
All right,
OCI stuff, but-
I'm waiting.
so this came out of the funniest place. We have a customer who managed to corrupt our metadata, and that got us in an absolute panic until we realized that they were corrupting literally anything and they had a RAID controller bug. But anyways, that got us to the point where we said, if we are going to change our suboptimal metadata formats, and maybe we should do some other things, like the fact that our drivers are steeply intermingled. Like, it's gotten worse than when it was in Dockerland. We have deeply intermingled the drivers and the rest of the code. There is effectively no independence between the overlay driver and the actual underlying storage. Any change at this point cascades through the entire library, and that has become deeply problematic for our ability to actually drive any changes that move this forward. We're at the point where, when I look at it, it's less painful for me to say we're going to have a legacy driver, or a legacy library rather, and then let's just rip the Band-Aid off, clean sheet design, and say the new installs are going to use this. Which is why the cryo people are here, because this is going to deeply affect them.
Wait, sorry, my favorite topic, but if we have separation between metadata and data, why is it super expensive, right? Like, so the beauty again.
That's the problem. We don't have a separation right now.
Well, but yeah, so, okay, there's two things, right? If you have ref links on the file system, everything gets very simple because,
here
hey,
we go.
yeah, but we can't always rely on that, so. But the cool thing about ComposeFS, right, is that unlike the default overlay driver, all the metadata, including the hard link count in each file, lives in the EROFS superblock. So you can share underlying storage. Like, yeah.
This is lovely for people who can use ComposeFS. The other half of this is that I'm interested in enabling some HPC people who are running. I have no idea how to describe what they're doing, but it is absolutely OCI non-compliant. And as such, there's no way I'm going to be able to upstream it into Podman. But at the same time, it's deeply interesting. It's used by multiple people. I would love to provide them with a driver that they can plug, or an interface rather, that they can plug in the equivalent of a containerd snapshotter. It would probably be more than that, but plug in whatever they're doing, and now they don't have to run a horrifying Podman wrapper that passes us root file systems as directories, because they've done all the work themselves. And basically, it's horrifying what they're doing. They're using OCI hooks to mount and unmount. Anyways, I basically want to give them a happier path than what they have now.
I have a kind of spicy question. Like, so we've been at this OCI thing for many years, and like a long time ago, OCI was, the thing, right? But now AI is the thing. It's like, I guess it's kind of like the browser thing. It's like, can we just start sharing more code? Like, how much do we need to, like, you know what I mean? Really, like, okay, we're gonna have a standard and all this stuff versus like, okay, no, we'll grow it.
That is the interesting thing. Like, how horrifying of an idea is it if Podman has the same snapshotter API as containerd? Or is that not a horrifying thing? Is that a great thing? Is that all of a sudden we have the same storage drivers, and any improvement made to one applies to both?
The only thing I'd warn about that is the way containerd is designed. We have a lot of we tried to make it composable where every piece is tightly scoped, and likewise the snapshotter is pretty tightly scoped. So like, you can use the snapshotter,
Yeah.
but it's such a low level equivalent that it either you start bringing in more pieces of containerd, or you're basically like building so much on top of it.
Yeah.
Maybe
you want to.
Yeah, if the snapshotter is the piece that is really helpful, then I mean,
It's the piece I'm most excited about, but I don't know. Is there a world where we use more? Probably. Is there a world where we use less? Also probably. Like I'm still gathering requirements for what this rewrite is going to look like. So I don't have a full set of use cases yet. I would love to share some code because that would make my life infinitely easier, but I don't know enough to say whether it's possible yet.
I mean, I think as a project, we're always supportive of that. I I would say just like for example, like I know how the other backend works, how everything is kind of, you know, you have your tar split and you have all of the tar streaming in and out. Like in Containerd, it's like, well, we have snapshotters, but then sometimes we have like a differ that's kind of tightly associated with that snapshotter, like the ArrowFS differ. The differ is responsible for taking some content, doesn't really matter what it is, just some content, and converting it to mounts, which is what the snapshotter would return. So like there is a differ that's going to take a tar stream and it's going to apply it to some mounts that the snapshotter return, the ArrowFS snapshotter return. You know, and it could mount it and untar it, or it can call makefs ArrowFS to like directly stream it in. So like that type of thing where it's like, well, it's like you have this, but then now you have this other component, and then now it's like,
Yeah.
okay, well, if you want to use that component, well, you know, it's like now you have the content component. If you have the content, so it's like they're pieces that are tightly scoped, but like they
Yeah.
fit together in like in a very specific way.
Architecturally speaking, I love the way you're going about things. My only, like when I ask questions about whether it's possible for code reuse, it's mostly, are we going to scope things the same way you did, or are we going to have a different set of tightly confined APIs? Like, I like snapshotters because I feel like it feels like one of the harder parts to write for me, one of the parts where we could get the most benefit from sharing code. But at the same time, it brings in other stuff. Yeah.
But snapshotters themselves are pretty simple. Like the implementations of them are pretty simple. I mean, I think we've seen more advanced
Yeah.
ones like this, some of the
That's
streaming
most,
ones, but yeah.
like I could get an overlay one running quickly. It's the thing that interests me is getting access to the ecosystem, if that makes sense.
I have a random question related to this. I couldn't find the docs. So Containerd always stores the compressed tar originally, right?
Yes.
And is the snapshot, is the whole architecture predicated on that? Because container libs doesn't, like Podman doesn't.
If you want to repush it, yes, we do not recreate in Containerd.
Right. Yeah, I guess, yeah, well, my question was, is the whole snapshot, like, is that just an optional thing? Like, in theory, I could turn that off in Containerd and everything else would just work?
Yeah,
I
you
would
don't,
just
you don't,
use
need-
what
yeah.
goes-
you don't need tars at all.
Okay, yeah.
As I said, we had the differ format or the differ interface we have takes content. We'll take basically the interfaces, give me a content descriptor and give me a set of mounts and it will do something. Like that's it. What it does is kind of up to the implementation. But like, yes, like normally it's tar. So like everything has to, every implementation has to be able to take a tar, otherwise it's useless.
Yeah, yeah. I guess I was just thinking there was a possibility that like some sort of uncompressed representation was just a cache from Containerd's perspective, right? And like it might require at some point being able to find the original compressed tar. Doesn't sound like that's the case.
I mean, so the content store, the way it works in Containerd days, we have the content store, which basically just mirrors what it just basically syncs what the registry has locally. It doesn't touch the data at all.
Right.
And like, it's only referenced by the manifest that came from the registry itself. So even if you touched it, you put something in there, the garbage collector would actually remove it as nothing would be using it. The thing that I mentioned about like tar mode and the ArrowFS snapshotter, I think right now that's taking it and copying it into it, but you could have the snapshotter use the content from the content store as well. We tend not to like, because that kind of violates the principle of like, these are two separate components. We don't usually like them to be like tightly coupled. So usually there's like a copy in between them. But we are thinking more about possibly having a next gen like content API that can handle like block devices or like basically empty files or like files that potentially have holes in them, and being able to use those from the snapshotter, and could chunk stuff. So that's one thing we've been talking about doing. From the snapshotter perspective, it wouldn't change the API, but it could allow more use cases for that.
One thing I think, just a random question, but this is something that I've been noodling on as part of the rewrite. Do you have a position on multiple concurrent stores?
Like what type of stores?
So basically concurrent image sources that you would have going, say, I would have my global directory where we have a bunch of read-only images, but then I'm gonna have a read-write directory here that's used on top of that, things like that.
We don't have that today. I mean, the snapshotters could do that, or you could have a different snapshotter for different like runtime classes. We've had people ask for that, but we haven't implemented anything like that.
Yeah,
I mean, I don't know if this is the exact same thing, but the CERN folks wrote a CVM FS snapshotter, which uses distributed store that's on every node, you know, in their HPC
Okay.
cluster that has the read-only
so that,
blobs.
so you would think of this as a snapshotter as opposed to, okay, because when I think of this, I usually think of, I've got an interface on top of the whole storage backend, if that makes sense. And
yeah.
then I would query that to say, oh, I have a store here that has these images, I have a store here that has these, but doing it. Snapshotter is a bit more elegant. It plugs into everything else, doesn't it?
Yeah, because then the other layers of container D don't need to know anything about that.
Yeah, fair enough.
Mhm.
We did run into a little bit of like, I feel like weirdness in the snapshotter API with the AeroFS stuff, because like, although I feel like we could just add a flag that basically says like, I'm preparing this snapshot for read-only basically, because like right now the interface for the snapshotter is like, it always creates something writable, you know, and then you commit it, it always creates something read-only.
Yeah.
And it's like for containers, like the containers never get committed. So like if you're preparing something for a container, then it's never gonna get like promoted, or however you put it, into like read-only storage. So like you could treat it differently. So like what we do in like AeroFS is like, we don't create the writable yet. We create like a directory where you could put it, or
Yeah.
a block device location where you could put it. But then when we actually go to do the differ will be like, okay, well, it's doing AeroFS, I'm just going to write the read-only file, and then you can do FS-Verity or whatever on top of that, you know, and it's going to be read-only, but like, it's not in like a separate location. I know some people have asked for that, like, can I put this in a separate location? I mean, you could support that though. I mean, some things, we usually don't like to change our like interfaces to add labels and stuff, since everything in container is like, all the interfaces have like the ability to add labels.
Oh, okay.
Fair enough.
Okay, well, we got up to 5. Good work, everybody. Thanks for meeting with us, and then let's keep talking, because this really gives us different things to think about for sure.
Yeah, and I think there's definitely areas we know that could be improved with like snapshots. I think I said some of them I think would probably be like labeling, and some of them like if there's some sort of like functionality that wants some consistency with, like, I mean, I think we're open to that.
Fair. I mean, I don't have a specific timeline on how soon we're gonna look into this, but it's probably full context. I'm working on Podman 6 effectively full-time now, which does exclude this. Like, it's too big to scope in. And also it doesn't, strictly speaking, have to be a breaking change if I support the two of them concurrently. So this is, I want to have a design done by very early next year, but I'm probably not going to get working on it until somewhere around spring. If that makes sense.
It's okay, Mark's gonna do it.
We'll farm the entire thing out to Cursor. We'll be done in 5 minutes.
That's supposed to be supposed to be what I was gonna say. Okay, thanks everybody for joining. I'm just gonna close the computer. You wanna say anything? Lauren? Okay.
Good.
Thanks, everyone. Have a great day.
Good to see you, Brandon.
Thanks,
Thanks
for-
thanks Phil for organizing, and thanks Neil for
Thanks.
volunteering your laptop.
My pleasure.
Yep. Thank you.
Cheers all.
Cheers.